All right, here's a real quick crash course in how to build an op-amp circuit. So the diagram that we're going to be using is for a 10x inverting amplifier, and the simplified diagram really so the triangle is the op-amp, and there's only two inputs and one output shown. There's a minus input, a plus input, and then the output. This more complete diagram that actually shows the power supply sources shows that there's actually 5 inputs on the op-amp circuit that we need in total. So we still have our minus and plus inputs. We have the output. Then we have this plus power supply and this minus supply. And so this is the circuit we're going to try to build. I'm going to see if I can do this in about 5 minutes. All right, so I've got, let me switch over. I'm going to switch back and forth between a couple different views. One of the views that's going to be useful is this one right here, which is the pin diagram. So I'm going to switch over to the camera. And you can actually see the physical chip right here. It's got 4 leads on the right, 4 leads on the left, and there's that little dot that kind of helps us orient the chip. And that dot is oriented in the exact same way as in the diagram here. So the first thing I need to do is I need a 4.7 ohm resistor to connect from the input to the minus. So basically it's going to come from the analog waveform generator to the minus input. So the minus input is pin 2 here, so second from the dot. And so I'm going to do 2 things. I am going to plug in my arbitrary waveform generator. I'll plug that into, say, like row 15 there, and I'm going to take my 4.7 kilo ohm resistor and have it connect between it's going to connect from that arbitrary waveform generator, which is yellow, and it's going to connect to pin 2. The angles make it a little hard to see, but that is plugged into pin 2. Alright, so now we switch back. We need a 47 kilo ohm resistor to jump over to the output. So the in minus is pin 2, the output is pin 6, which is second from the bottom right. Alright, so if we switch over here, I'm going to take the other resistor and kind of building this in pretty much in the most compact possible way. So you can see that resistor kind of jump over between those pins, between pin 2 and pin 6. Alright, let's see what's next. So then we need to decide where we're going to measure the oscilloscope. So my oscilloscope, I lost my orange cable, but I'm going to say measure channel 1 on the input signal. So this is actually let me switch back over. So I'm using my oscilloscope channel 1 to monitor the arbitrary waveform generator, and I'm going to use my oscilloscope channel 2 to measure the output. So that's good. So if we look at the diagram, the main thing we're missing right now are a couple of ground connections. So we need to connect the plus oscilloscope input to ground. The plus oscilloscope input is pin 3, so that's going to need to go over to ground. Alright, so I'll use a little jumper. We'll connect pin 3 over to ground. We'll also need to make sure the open scope has a connection to ground, so I'm going to do that up here. So that's my black ground cable, and this is just a jumper pointing right up there. So that jumper is going from ground over to pin 3, which is the plus input. Alright, and alright, so that covers the analog waveform generator, the 4.7 kilo ohm, the 47 kilo ohm, the output, where to measure the oscilloscope. It covers that ground connection. The only 2 other things we need are plus and minus 4 volts, and those are going to be supplied by the power supply on the open scope. So I'm going to use the power supply 1, or V1 it's labeled. So I'm going to use power supply V1 to be the plus. Now let me look at the diagram one last time. So the plus power supply is pin 7 over here. So that's going to be 4 volts. So here I just plug in, that's my plus power supply. And then got to look at the diagram one last time. Got VCC minus, so that's pin 4. That's going to be minus 4. That is the last cable that needs to be plugged in. All right, so let's plug it in right next to it. Okay, so I mean it's a little bit crowded in there, but we do have a lot of connections we've made. We've actually got 5, we've got actually 6 connections from the open scope to this circuit, including the ground, and then we've got the 2 resistors. And so really, I mean, that's all it is. You just kind of, I think one thing that makes this a little easier is that the orientation of the chip and the orientation of the diagram were similar. And let me just do one last thing. So I'm going to go to the Digilent. And it looks like it remembered my DC supply voltages, so those might be right. I'm going to just turn on the Waveform Generator. I'll set it to like a 1, actually we can't do 1 volt peak to peak because this thing is supposed to be times 10. And I'm going to give it a 1 kilohertz signal. And let me turn that on. Let me run. All right, and so these are actually on very different scales right now. So, so that's on a 200 millivolt per division scale. Yeah. So actually, this is pretty good right here. So the orange is channel 1 is the input. That is actually on the same 200 millivolt per division scale as the blue. The blue is the output, and you can see that that wherever the orange has a minimum, the blue has a maximum. So it's an inverted amplifier. And if we were roughly to measure the amplitude there, that's about 63 millivolts, 66 millivolts. That's about minus 30 some. So it's about 100 millivolts peak to peak, and then as it should be, and then this is going from about 430 to about minus 520, so about 1000 millivolts. So we're seeing the roughly factor of 10 amplification, and that is the times 10 amplifier and how it's hooked up, and this is roughly what your data should look like. So